Hello, boys and girls. The first thing we're going to do is we are going to make our X factor sheet. So let's start with 1 in the corner, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we're going to use one of our math practices, which is finding repetition. So let's see. Let's go down this way as we're setting everything up. 5, 6, 7, 8, 9, 10, 11, 12, 13. And what do we do first? We are going to double the ones to get the twos, right? 2 plus 2 is 4. 3 plus 3 is 6. 4 plus 4 is 8. 5 plus 5 is 10. 6 plus 6 is 12. 7 plus 7 is 14. 8 plus 8 is 16. 9 plus 9 is 18. 10 plus 10 is 20. 11 plus 11 is 22. 12 plus 12 is 24. 13 plus 13 is 26. So we doubled the ones to get the twos. And what do you notice is happening each time we go to the next number in the pattern? If you said they are increasing by 2, you are correct. And look, they're also increasing by 2 going down vertically. So now we're going to go back to first grade when you first learned to count by 5s. So let's count. Let's go to 5 and 5, 10, 15, 20. We want to keep these numbers aligned. 25, 30, 35, 40, 45, 50, 55, 60, 65. The reason I'm using lined paper is because I know many of us, including me, do not have graph paper at our home right now. You can print it offline. You could also turn your paper like this so that you have columns, but I am going to just keep it like this and do my best to keep everything aligned. Then remember when you were in first grade, you also learned to count by 10s. So let's go to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Oh, it's getting hard to keep them aligned. 130. Now, if we go back to the 5s, what do you notice the pattern is? In the 1s place. And then in the 10s. And look at the 10s. What pattern do you see? In the 1s and the 10s place. All right. So now, next, we are going to go to the 11s. All right. Now, we are going to simply double the single digit factors, and then we will add 11 to the double digit factors. So 22, 33, 44, 55, 66, 77, 88, 99. And then I can come up here, 10, times 11. Okay, and I can put that there. And now we're going to add 11. Add the ones, add the tens, and you get 121. Then let's add 11 again to the ones place and the tens place, and you get 132. And then let's add 11 again to the ones, add the tens, and you get 143. All right, now what we are going to do is we are going to double the 2's to get the 4's. So if I come over here, 4 plus 4 is 8. 6 plus 6 is 12. 8 plus 8 is 16. 10 plus 10 is 20. 12 plus 12 is 24. 14 plus 14 is 28. 16 plus 16 is 32. Now you know why you had to learn your doubles addition in 2nd grade. 18 plus 18 is 36. 20 plus 20 is 40. 22 plus 22 is 44. 24 plus 24 is 48. And 26 plus 26 is 52. Very good. Now what pattern do you see happening here with 4? Are the numbers getting greater or smaller? All right, so now what we're going to do is we're going to double the 4's to get the 8's. So let's see. 8 plus 8 is 16. 12 plus 12 is 24. 16 plus 16 is 32. 20 plus 20 is 40. 24 plus 24 is 48. 28 plus 28 is 56. And now you have one of those multiplication facts that students often get stumped on. Look, you have 8 times 7 is 56. All right, and then we are going to add 32 plus 32 is 64. 36 plus 36 is 72. 40 plus 40 is 80. 44 plus 44 is 88. 48 plus 48 is 96. And 52 plus 52 is 104. I hope I did not say 130. Oh dear, because and is a decimal in math language, but you never know. Who knows what I said? Anyway, so now we are going to do our 3's. So our pattern with everything in our X factor chart so far has been that we add the number or the factor to itself to get, okay, the first one. So 3 plus 3 is 6. All right, and so now we're just going to keep adding 3 to these multiples. So 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. And now we are going to double the 3's to get the 6's. So 3 plus 3 is 6. 6 plus 6 is 12. 9 plus 9 is 18. 12 plus 12 is 24. 15 plus 15 is 30. 18 plus 18 is 36. 21 plus 21 is 42. And now we have another one of those math facts that students often get stumped on, but here we have the answer. 7 times 6 is 42, or 6 times 42 is 7. Boom. All right, let's continue. 48, we're continuing to add 6. 54, 60, 66, 72, and 78. All right, now are you ready to do the nines? And let me tell you what my sister-in-law told me. She said, all you have to do is, over here, you can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you just go backwards from the bottom up. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe that wasn't backwards. Maybe that was reverse. I don't know. Anyway, so now what we're going to do is we look at this, right? 1 times 9 is 9. 2 times 9 is 18. And we're just going to continue writing these multiples. So 18, 27, 36, 45, 54, 63, 72, 81, 90. And now what has the pattern been? We've been adding 9 to each of these multiples. So now we can either say 11 times 9. Oh no. Oh, there you go. There has to be some mistake. Remember, mistakes are expected, respected, inspected, corrected. I'm sure that made a lot of sense to me when I wrote it down a few minutes ago. Oh, life. Okay, so let's keep going. 99, and then 99 plus 9 is 108. And then 108 plus 9 is 117. Multiples of 13 always look like prime numbers to me, right? But they're not. They're composite numbers. All right, now let's take a peek. So are any of you seeing any other patterns? What do you think we can do to get 12? We can double the 6's to get the 12s. So 6 plus 6 is 12. 12 plus 12 is 24. And then remember, we're adding this factor to itself, right? So 2 times. So we're going to 24, and now, so the next one will be 36. And you see anywhere else that we can get the multiples of 12 that we've already written down that we could take a little peek at? Right here, right? Except for 12 times 7 or 7 times 12. So we're just going to take a peek, and I will try very hard to copy things correctly. So we are at 48, 60, 72. We will skip 12 times 7. And we will go directly on to 12 times. I'm a little, okay. Oh, that's 9, okay. 96, I just get the giggles about myself sometimes. Okay, 96, and then 120. 132. Oh, I have to squeeze them. And so now we're adding 12, right? So let's come here and let's finish this. So if I add 12 to 132, I get 144. And then if I add 12 to 144, I get 156. And now let's go back here to 12 times 7. I will come to 72 and I will add 12 and I get 86. Wow. So now we just, why did I put that? 12 times, oh yeah, that is correct. Did I say 86 or 84? Can't remember. Can't and shan't. Okay, so now what we're doing is we're going to look for a place where we can get our 7s. Right? So we're going to carefully copy 7 times 2, right? 7 times 2, or 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. And some of you might be thinking, wait a minute. 5 times 7 is 35, and 7 times 5 is 35. That's the same product or answer. That's correct. That's because of commutative property of multiplication, right? It doesn't matter if you switch the factors around in multiplication. You're going to get the same product. All right, 6 times 7 is 42. 7 times 8 is 56. 7 times 9 is 63. We've already done that. 7 times 10 is 70. 7 times 11, 77. 7 times 12 is 84. And then we add on 7. And we get one of those numbers that looks like a prime, 91. That always looks like a prime to me, but it is not. It is a composite number. Because besides 1 times 91 equaling 91, 7 times 13 equals 91. Or if you use commutative property of multiplication, 13 times 7 equals 91. And now we are left with 7 times 7, which is always one of those math facts that students struggle to remember. But you do not have to. Come here to 7 times 6 is 42, and you are going to add 7 to that multiple, and you will get 49. And now where can you look to find the multiples of 13? Right here. The only one we will not have will be 13. But we shall. Okay, so let's look. 26, 39, 52, 65, 78, 91, 104, 117, 130, 143, 156. I'm trying to squeeze them in. And now we are going to add 13 to this multiple of 13. And we get another one of those numbers that appears to be a prime, but it is not. And now that we have finished our X factor sheet, we will be able to use it for multiplication facts, division facts, reducing fractions, finding equivalent fractions, and finding multiples and factors of numbers. So exciting!